we're going to get started on our lesson for tonight. Okay, and tonight we are doing revision, all right, of our similarity and congruency and how to prove similarity and congruency, how to prove triangles are congruent. So we're going to go over some examples together. That's the best way to practice it. All right, we're going to make sure that we have our structure down. We're going to go through a variety of different examples together tonight, and we're going to make sure that you guys fully understand this. A reminder, at the end of this lesson, there is a quiz for you to do, so you're going to be able to test your skills in the quiz. If you still don't think that you get this section of maths, not to panic. You can go back, you can watch the videos again, you can pause it, you can go back, you can make sure that you understand. Okay, let's have a look. So it says, prove that the following pairs of triangles are congruent. Write your proof out correctly, giving reasons for each statement. State the other facts that will be equal as a result. So we're making sure that we read the full question here, guys. So the first thing they want us to do is they want us to prove that the triangles are congruent. And the second thing that they want us to do is they then want us to tell them what else will be equal because the triangles are congruent. So for the first example, they've given us triangle ACE and they've given us triangle HGJ. All right. So we're going to make sure that we are setting this up correctly because that's your first step to getting this done right. Okay, that's your first step to making sure that you get full marks for this section. All right, for similarity and congruency is making sure you get your structure correct, guys. If you can just remember how to set it up correctly, the rest is all really easy. So the first thing that we want to do when we're doing this kind of question is we want to start with our opening statement. We're going to start with, in triangle ACE and triangle HGJ. Okay, so that's our opening statement. In triangle ACE and triangle HGJ. All right, number one. Okay, the thing that's sticking out to me the most, all right, the thing that's coming out at me the most is the fact that I've got two little squares in both of these triangles. What do those two little squares mean? You can tell me in the chat if you really want to, okay? Or you can raise your hand if you want, but to me, those two little squares, when I learned in maths, one of the first thing I learned is that if they've got a square, it means great, well done, guys, it's 90 degrees. So I'm going to go say to myself, angle E is equal to angle J, which is equal to 90 degrees. Now, if I've ever taught you geometry in any sort of lesson, then you should know what's coming next. You should know. I'm going to say, why? Your sob sister, geometry, she's back. That's right. Why? Why is that true? Why is it 90 degrees? Did you guys have to go prove that? No, you didn't have to go prove that. What was it? It was given. Okay, so that's the first thing. That was given. All right, it's 90 degrees. What is 90 degrees? Okay, so at the same time while I'm doing this, I'm going to go write in pencil next to this for myself. All right, so I know that 90 degrees, it's got a degree sign on it. So it can either be an angle or it can also be a right angle here. So either it's an angle because it says 90 degrees or it's a right angle. So just in pencil, I'm just telling myself on the side exactly what those things are. Number two. All right, lots of people telling me in the chat. Well done. Thank you. Well done, guys. So AC is equal to, right, so here is my line AC. When a line has two dashes on it, what does it mean about those two dashes? Those two dashes mean that the lines are equal. Good. Okay. It's very different to when the line has two arrows on it. When a line has two arrows on it, okay, so when a line looks like this, all right, so when you've got lines like this next to each other, all right, and they've got this on it instead, what does that mean? Good, that means parallel. Is parallel and equal the same thing, guys? Just highlighting this for you. Does parallel automatically mean that the lines are equal? No, you should be saying to yourself, parallel does not automatically mean that the lines are equal. So be careful, especially in the section. We're going to go look at a question just now where we're going to look at this, okay? Parallel does not mean that they're automatically equal, okay? So be careful. All right, so for this one, AC is going to be equal to H, G. And again, sub-sister in your head whining at you. She should be saying why, because given. I'm picking up my pencil at the same time. Remember, this isn't part of my reasoning or anything like that. I'm just doing it to help you guys on the side. All right. What are these things that we've just done? Okay. In triangles, you get angles and you get sides. Hey. So I'm going to tell myself that this was a side. But it's a special kind of side. All right, it's a special kind of side. What can I call this side? It's the side that's opposite to the right angle. What is that side called? That special kind of side, the one that's opposite to the right angle. It's got a special name. It's a very fancy name. It's a long one. All right, it's known as the hypotenuse. Now, please don't make me spell the word hypotenuse because my spelling is shocking. So I'm just going to go put here H for hypotenuse. All right. Moving on, number 3. Okay, moving on, number 3. The last thing I can see here is that I've got this side and this side with some dashes in it. And so I'm going to say CE is equal to GJ, Y, given. Right, is there anything special about this side? Not really, hey? Nothing special about this side, it's just a side. All right, so at this stage now, we've come to now say this to ourselves, because in congruency, when we're proving something is congruent, okay, you always need to say to yourself, if I'm proving congruency, okay, and normally it's for triangles, in a triangle, there's 3 sides, right? In a triangle, there's 3 angles. So how many reasons do I need for congruency? I always need 3 reasons. All right. So I've got 1, 2, 3, check. So now I can say to myself, therefore, triangle ACE, okay, is congruent to triangle HGJ. All right, and in your ear, the sub-sister's going, why? So I need to go tell them why now. All right, there's 4 different things you can use for congruency. The first one is side, side, side. So all the sides are equal. Here, we don't have that, okay, because there was an angle thrown in there. All right. The second one you can use, okay, is SAA, right? South African Airways, no. Side, angle, angle, all right. And in that case, it doesn't matter where the side is, all right? As long as you've got a side and you've got 2 angles, you're all good, all right? Again, in this case, I don't have SAA here, all right. The third one you can use, guys, the third one you can use is, like somebody said there, ASS or SSA, okay? But for it to be that, for you to have, okay, side, side, angle, or side, angle, side, which is actually the way I like to have it, which is similar here because we've got an angle, a side, and a side, all right? When you have that happening, okay, the angle needs to fall between those two equal sides. So I like to say this. I'm always like, when those two sides are equal, okay, it's almost like those sides are hugging that angle. So you've got your two equal sides in your triangle, and then those two equal sides are hugging that angle. They say that the angle is included. It's falling in between those sides. But think of it as like, there's your two equal sides, and those two equal sides are hugging the angle. So in this case, if we're looking at it, is this angle being hugged by those two equal sides? No, it's not. So just like you've said there, what am I using instead? I'm using RHS, the fourth reason. So RHS, right angle, hypotenuse, and side. Let's finish it off, because now they've said to me, also write what else is going to be equal. So we're going to say, therefore, what else do we know is going to be equal? Okay, angle A is going to be equal to angle H. Angle C is going to be equal to angle G. Okay, so we know that. Why do we know that? Because the two triangles are congruent, okay? All right, and what else is the third thing that we also know? Side AE is going to be equal to side HJ. Why? Because triangle ACE is congruent to triangle HGJ. Okay. All right. Make sure you've got that in a screenshot. Make sure you're all okay. All right, I'm gonna move it down slightly. If you're still busy, don't stress. I'm just gonna bring it down to the next one for everybody. Okay. Oh, the next one is here somewhere. Maybe I'll bring the next one up for you guys, and that might make our lives a bit easier. Okay, so there's the previous one for those people that were still writing, and we're going to do the next one. All right, so let's have a look at the next one. All right, we're going to have a look at this next one, and then we're going to have a look at the kind of examples that you're going to get in grade 9. Okay, so we're going to level it up a little bit. Okay, so we're going to lay out our question again. We're going to say, in triangles, HGJ and triangle WY, oopsie, I'm missing a letter here. I'm going to call it Z. All right, so in those two triangles, all right, number one. Okay, number one. All right, who is going to help me out here? Who's helping me out with this one? Anyone brave? Who's brave to raise their hand and help me out? I don't want to talk to myself all night. Who's brave? Come on. Come on. Anyone who's brave? Come on, grade 9s. You can only get it right or wrong. Oh, thank goodness. Omo.
Hello, ma'am.
Hi. How are you?
I'm good. Yourself, ma'am?
I'm good. Thank you for being brave. Right, let's go. First reason, what have you got?
Ma'am, angle H is equal to angle Z.
Well done. Angle H is equal to angle Z, and it's always good to tell them what it's equal to, hey? So it's equal to 46 degrees. Do you agree?
46. Given.
Why?
It is given.
Thank you. Well done. Right, give me your second reason.
I is equal to Y.
Okay, so we've got angle J is equal to, that's okay. It looks weird on the screen, I get it. Equals angle Y, which is equal to 76 degrees. Why?
Given.
given. I think you guys just like me saying that. All right. And the last one, what's the last one?
I haven't worked it out yet.
That's okay. Let's have a look here. Do we see an equal side? Maybe. What about this?
GH and WZ
Good.
are parallel.
Nice.
Equal.
Careful, not parallel. Hey, careful. So
They're equal.
GH, good, is equal to WZ. Reason?
Given.
Given. Awesome. Well done. Thanks, Omar, for helping me out. Wade, why do you say I need to stop saying why? It's the best thing. You're never going to forget it in your exam. It's going to be ringing in your head. It's going to be ringing in your head. I'm glad. Okay, here we go. So now I need to give my reasons. Okay, now I need to give so I need to state my triangles now. So I'm going to try to be clever. I'm going to say, therefore, triangle HGJ is going to be congruent to triangle. And now I need to be careful, guys, because I need to name this properly. So angle H was equal to angle Z, all right? Angle G is going to be equal to angle W, and angle Y was equal to angle J. So all I did was I changed my letters around a little bit so that they matched up. All right. Now, let's go use my pencil quickly. This wasn't a special kind of angle, it was just an angle. This wasn't a special kind of angle, it was just an angle. And this was a side. So what's my reason going to be here? It's going to be side, angle, angle. Does it matter where the side is? No, it does not matter where the side is. Okay, it doesn't matter where the side is. All right, all that matters is that you've got a side included in the mix. So now I'm going to go tell them what else is equal because I want to finish off and I want to get full marks. So I'm going to say, therefore, angle G is going to be equal to angle W. And I'm going to say WJ, oh, not WJ. What am I saying? Guys. I'm going to say GJ is going to be equal to WY. And I'm going to say HJ is going to be equal to ZY. And the reason for that is because triangle HGJ is congruent, I'm running out of space, to triangle ZWJ. Done. Full marks. Full marks. Okay. So guys, that takes care of it if we're given like nice, easy ones, okay? Like nice, easy ones. They're nice and easy. We can get all the answers. It's really clear. They've given us two triangles. They're right next to each other. But you all know that your exams are coming up soon, all right? And it's not as always as easy as that. So I'm going to give you 2 seconds just to take a screenshot, just in case you need it. All right, we can always come back and take a screenshot at a later stage. Okay, so that's all good as well. If you need to come back, let me know. But here we go. Time for you to take a screenshot. Okay, let's have a look at what happens when it's not always the case of it being as simple and easy, because for some reason you guys think that teachers are always out to get you. So let's have a look. All right. They say to me, number 1, first, by proving that the one triangle is congruent to the other triangles, okay? So first of all, they're saying, prove to me first that that triangle is congruent to that triangle, okay? So by proving the one triangle is congruent to that triangle, prove that JC is equal to JH. So, oh my goodness, all right, now we have to look at something else, okay? Let's go and have a look at this, all right? They've given me little stars. They've given me little hashes. All right. I need to go prove that these two triangles are congruent. So I'm going to go say to myself, still using the exact same format, guys, the same format. So I'm going to say in triangle, JCO, okay, and triangle, JHO. All right, using the same formats, all right, to answer the question. Okay. What's really great is sometimes the way that they've named the triangles can help you as well. Okay, but in this case, we're going to first go and have a look at what if they drawn on my picture, because I'm seeing some stars, I'm seeing some hashtags. Let's start with the stars. Let's start with those stars. So I'm going to go use some colors to highlight it to you. Can you see they've got a star here and they've got a star here? So what is that telling me? That's telling me that the two angles are equal to each other. So I'm going to start off by that. I'm going to say number one, angle, whoopsie. All right, I'm going to say angle O1 is equal to angle O2. They didn't tell me what it was equal to. They didn't say what it was equal to. However, it was given. Am I going to tell them it's equal to a star? No, because I'm going to look silly if I tell them it's equal to a star. That's not a value, okay? But it was given. All right. Number two, let's pull out that trusty highlighter again. I've got a hashtag. I've got a hashtag. So angle C is equal to angle H. Is it equal to a hashtag? No, that's not a value, okay? But it is given. All right. Now, for me to prove congruency, I've got to have triangles have three angles, triangles have three sides. I've got to have three reasons. All right, there's four different things that I can use for congruency. I can either have side angle side, I can have side angle angle, I can have RHS, or I can have side side side. So far, I've got angle, angle. Now be careful. This is where some students go and they get themselves so confused. They're like, yeah, but I can also prove that those two angles are equal to each other. Guys, don't go down that route, okay? Because angle, angle, angle is not congruency. There are four things for congruency. We've just said them again and again and again. Be careful, okay? What I want you to notice here with this, have a look here at this line. Is that the same line that's making up triangle JCO and the same line that's making up triangle JHO? Is it common? Is it a common line? Yes, it is. The two triangles have that line in common. So for number 3, there's two different ways to write this. Either you can say to yourself, JO is common. Okay, so you can either just say there, JO is common, done. Or you can say, or you can say JO equals JO reason common. So that's two different ways that you can say it. All right. And so this is going to be a side. So now we're going to say, therefore, triangle JCO is congruent to triangle JHO, reason, angle, whoopsie, reason, angle, angle, side. Close off my brackets. Okay. Tando's asking me, ma'am, how is it common? Tando, it's common because look at it. Is it in the one triangle and is it in the other triangle? In other words, is it in common? Like, do they have it in common, both triangles? So instead of thinking of it being common, think of it being, is it in common? So yes, it's in common. In other words, it's the same line. That's what common means. It's the exact same line. Okay, that's what common means. All right. It just means it's the same line. So therefore, because it's the same line, it means it's equal. All right. And we're going to finish it off. So we're going to say, therefore, JC is equal to JH. Reason, because you can't just say that in geometry. You can't just leave that hanging there. Reason triangle JCO is congruent to triangle JH. Okay. All right. Bushes are saying, ma'am, can't say similar instead of common. You could say similar, I suppose, but it's not really similar. The line's not similar. The line is common. It's a common line, is how we say it. Okay, so it's a common line, not a similar line. Common line. All right. Jordan, you're saying to me not AAS, SAA. You can say it either way, Jordan. It's really the same thing. Okay, you could say ASA, any way you want to say it. All right. Okay, guys, let's have a look at another one. Let's have a look at another one. All right, so I'm going to make that a little bit smaller in case you want to take a screenshot of that one. Okay, I'm going to bring this one up so that we've got it on the same screen for now. Okay, so just while you're taking a screenshot, and I'm going to read it for you, it says, by proving that triangle ECG is congruent to triangle YCH, prove that GC is equal to HC. So now this was the one that I said to you, be careful that they don't trick you. Okay? Be careful that they don't trick you. All right. So be careful here that they don't trick you, guys. Okay. Good. We're seeing vert-op angles. All right. Okay, I want to make this a little bit bigger for myself. Okay, so we're going to say, using the same structure, I'm bored of using this color pen. I'm going to change my color pen. So I'm going to say in triangle ECG and triangle, whoopsie daisy, YDH. All right. Let's start with things that we know and that we don't have to prove already. So number one. Okay, Tando's telling us, thanks Tando, EC is equal to CY, reason given. Thank you, Tando. Thank you. Well done. Okay, so we saw that EC was equal to CY, reason given. Number two. Okay, I agree with you. When I see two triangles and they're on top of each other like that and the lines are crossing over, my mind automatically goes to vert-op angles. Vertically opposite angles are the easiest ones to get. They are in the same vertex and they are opposite to each other. So if you're not seeing vert-op angles, I'm going to go highlight it for you here quickly. So here is where the vertexes are opposite to each other. And so this angle and this angle are going to be equal to each other. So we're going to say here that angle C2 is going to be equal to angle C1 Y vert op angles. Okay, vert op angles. All right. Now, I need a third reason. So I've got that the two sides are equal, okay? And I need a third reason. Now, be careful with your third reason, all right? Are parallel lines one of the reasons for congruency? No. So be careful there, okay? That is not one of the reasons for congruency, parallel lines. All right. Does parallel lines automatically make the lines equal? No, so be careful there as well, okay? But what do we know about parallel lines? Well, if I had to go and highlight this parallel line and this parallel line, some letters come into focus here, some letters, okay? So remember when you did parallel lines, all right, in geometry, there's 3 letters that you're normally looking for, either an F or a U, or some teachers say an N. I always say a Z. I always look for the Z. I don't look for an N, okay? All right. I say a Z because Z is like the alternate letter. It's like the one that I use alternate. It's like, oh, so when I use, oh, the alternative one right at the end. Okay. All right. So I'm looking for the Z. And in this case, that means that this angle over here, and if I follow the Z, is going to be equal to that angle over there. So I'm going to say angle E is going to be equal to angle Y. Reason, alternate angles equal, comma, EG is parallel to HY. Okay. All right. Now I can say that therefore triangle ECG is congruent to triangle YCH. Reason, I'm going to go do my reasons quickly. I see that there was a hand up, the hand's gone, okay? Somebody's saying to me, ma'am, can you say G and H instead? Of course you can. Of course you can. We'll have a look at that now. All right, so this was a side. This is an angle, guys, and this is an angle. So here I'm going to say side, angle, angle. And that means that therefore GC is equal to HC. Reason triangle ECG is congruent to triangle YCH. Okay. So yes, of course you can. All right. Okay. Somebody saying to me, ma'am, can you use angle G is equal to angle H instead of angle E is equal to angle Y? Of course you can do that. Of course you can do that. You can use those angles instead because those are also alternate angles. It'll give you another angle, which will still be SAA. That's perfect. Okay, that's perfect. All right. Okay. All right. Sia, do you have a question for me?
Hello,
Hi,
ma'am.
Sia. Hi, what's your question?
Ma'am, I wanted to ask if we can say that triangle EGC2 is vertically opposite to triangle CHY.
If it's a vertically opposite triangle, the whole triangle is vertically opposite, absolutely. But what are you trying to prove with that? What are you trying to prove that they're incongruent to each other?
I was actually thinking that if I was actually thinking that the whole triangle is just vertically opposite to each other.
Yeah, absolutely. Yeah. See, of course they're vertically opposite to each other. The whole triangle is. I don't know if we could say that they're vertically opposite, because when we're looking at vertically opposite, we're normally using that as angles. And we could say that they're opposite to each other. You could maybe say vertically. Yeah, actually, yeah. I'm happy to say vertically opposite. Yeah. Yeah.
So if you write that in the test, you can still get it right, though.
Yeah, I don't think, but in the test, they probably wouldn't ask you that question. But yeah. But you never know, because somebody said to me just now, your teachers are, somebody messaged me and said, man, my teacher's definitely out to get me. So you never know. I don't know. Maybe your teacher's also out to get you. I don't know. I doubt it though. Okay, cool. Good luck.
Thank you, ma'am.
All right. So guys, I want to do one more question with you before our lesson ends because our time is so short together. Time is so short together. And this is one last question, okay, where this is looking at two questions that have right angles, okay? So they right angles and they're in a circle, all right? So they right angles and they're in a circle, okay? It's a really great example. This one comes up all the time, okay, in grade 9. All right, I've seen it so many times in a grade 9 exam. It's there, it's always there. So let's have a look. Okay, so now I've got triangles that are inside of circles. Oh my goodness, what are we going to do? So what I'm going to remind you of here, if you normally get a circle, I want your brain to go immediately to the fact that in a circle, what do we get? We get radii, okay? And what do radii mean? All right, radii are all equal. Okay, so what are radii? Radii is the distance from the center to the edge. So do not forget about radii or radius, if you've heard of a radius before. Okay, and it means that all the radius are going to be equal in a circle. So when they put triangles into a circle, what are they going to try to trick you with or catch you with? It's the fact that you've got radii or radius. Okay, so here we go. We're going to say in triangle OZW and triangle OZX. Number one. Okay, number one, let's go. We know that angle Z1 is equal to angle Z2, which equals 90 degrees. Why? Given. Okay, so we know that. All right, we know that. Number two, I've just spoken to you about radii. So don't forget about radii. Are there radii in the circle? Is there, okay, lines from the center of the circle to the edge? Yes, there are. OW is equal to OX, right? Why is that true? Because they are radii. And that's the reason. The reason is because they are radii. All right. You don't even have to go and explain it. You don't have to go tell them in a circle the radii. No, you just tell them radii. All right. And number three, somebody said to me just now, who is it that's told me this? Okay, there's somebody else has told me. Well done, guys. Well done. Okay, well done. OZ is common. Good. So OZ is here. It's in both those triangles. Both those triangles lie on that line. Okay. So OZ is common. Bushra is asking me, ma'am, what does radii mean? Radii mean that they are radiuses in the circle. What is a radius? A radius is the measurement from the center of the circle to the edge of the circle. Okay, a radii, radius or radii. Okay, so more than one radius is called a radii. So therefore, triangle OZW is congruent to triangle OZX. Reason. Now we have to go give them a reason. So I definitely had a right angle. Okay, I definitely had a right angle. If I look at OW and I look at OX, those are opposite to the right angles. So those are hypotenuse, hey guys? Okay, so those are definitely hypotenuse. And I have another side. So R, oh dear, my pen is going a little bit flat. HS. Therefore, WZ is equal to XZ. Reason, triangle OZW is congruent to triangle OZX. Okay. All right. Always remember to finish off your question. So for this question, they ask you to prove, or they ask you to prove that WZ is equal to XZ. And how did we prove that? Because the two triangles are congruent. Okay. Let's see here. Zianda's asking me, Miss, how do we know that OW and OX are the radii? We know that they are the radii because they told us that O is the center of the circle. So if O is the center of the circle, okay, that must mean that OW is a radii and OX is a radii. Okay, whenever they put some triangles inside of a circle, I want you to always remember this for the whole time you do maths. Okay, from now in grade 9, all the way up to when you do matric, guys, when they put a triangle inside of a circle and there's a center, you're looking for radii and you're looking for the diameter. All right. Okay. Is there anyone else who has a question? Is there anyone who might want me to go back to another question for them? Is OZ a radii? Okay, so Wadey, OZ is not a radii, Wadey. The reason why is because Z is not touching the edge of the circle. So can you see, Wadey, that Z is sitting over there, hey? If Z was sitting over here, then it would be a radii, but it's not, okay? It's sitting above the edge of the circle. All right, I'm going to ask Miss Simone if Miss Simone will share the quiz link with you guys, okay? So Miss Simone is going to share the quiz link with you guys. And Diswa, you're asking me, can I explain RHS? You're a bit confused how it differs from SAS. So remember, and Diswa, for SAS, okay, I'm going to draw it here for you again. So for SAS, you'll have a triangle that'll look like this, and the angle must be what we call included. So it's almost like you've got the two arms that are equal, okay, and it's like those arms are hugging that angle, okay? So the arms are hugging that angle, all right? Because those arms are hugging that angle, that's what makes it SAS. For right angle hypotenuse side, those arms, they're not hugging that angle. It's a right angle, a hypotenuse, and another side. It doesn't mean that you have to be hugging the angle. All right. Zianda's asking, how did we prove that WZ is equal to XZ? It's because, Zianda, because that the two triangles are now congruent, okay? Because the two triangles are congruent, it means that those two sides are equal. So when you prove the two triangles are congruent, it then automatically means that everything else is equal. That's how you prove that they're congruent. Okay, so in order to prove that two sides are equal in triangles, you need to prove that they are congruent.